Okay, so we're going to look at the rules of probability, how they're written, just the language. It's a little weird, but it's really not that bad. It's the stuff we've already talked about. So we're going to look at rules of probability, and I can solve problems using probability. Okay, so here's the boring but important stuff to know. Two events are mutually exclusive. You'll see this word a lot, or sometimes they'll say disjoint if they cannot occur at the same time. That's what mutually exclusive means. The probability that event A occurs given that event B has occurred is called conditional probability. We've already watched a video on that and we've taken notes. The conditional probability of event A given event B is denoted by this symbol right here. We also talked about a complement of an event, so it's the event not happening. So the probability that event A will not occur looks like this. The probability that events A and B both occur is the probability of the intersection, and it's denoted like this, so that up and down is called intersection. The probability that events A or B occur is the probability of the union of A and B. So when you see the little U symbol, that means union. And then lastly, we talked about this. If the occurrence of event A changes the probability of event B, then we say it's dependent. If they do not change for each other, that's independent. So that's just boring vocabulary, terminology stuff, and then some weird symbolic forms. Okay. So there are some addition rules. Addition rule 1, when two events A and B are mutually exclusive, remember that means they cannot happen at the same time, the probability that A or B will occur is the sum of the probability of each event. So sometimes you might see it written like this, but this is actually the same thing. Okay, so we're going to do these two examples. So the probability single six-sided dice roll. What is the probability of rolling a 2 or a 5? So the probability of rolling a 2 is 1 out of 6. The probability of rolling a 5 is 1 out of 6. If I add those together, I get 2 out of 6, which reduces to 1/3. That's the addition rule. So a spinner has 4 equal sectors colored yellow, blue, green, and red. What is the probability of landing on red or blue after spinning? So the probability of red is 1 out of 4. The probability of blue is 1 out of 4. If I add those together, I get 2 out of 4, which is the same thing as 1 out of 2. Alright, then there's another addition rule. When two events A and B are not mutually exclusive, the probability that A or B will occur is the sum of the probability of each event minus the probability that they both occur at the same time. So here's the symbolic notation. Alright, and we're going to do some examples. Okay, so a single card is chosen at random from a standard deck of 52 playing cards. What is the probability of choosing a king or a club? So, you should know that there are 4 kings in a deck of cards. There are 13 clubs, but there's 1 card that is a king and it's also a club. So when we do this, we get 16 out of 52, which reduces to 4 out of 13. Alright, and then we'll do example 2. Alright, so in a math class of 30 students, 17 are boys and 13 are girls. On a unit test, 4 boys and 5 girls made an A. If a student is chosen at random from this class, what is the probability of choosing a girl or an A student? So there are 13 out of 30 girls plus, let's see, 9 people made an A, but 5 of those were girls. Alright, so when we do all this together, we get 17 out of 30. So this is your subtraction rule, also called a complement. The probability that A will occur is equal to 1 minus the probability that A will not occur. Suppose, for example, the probability that Bill will graduate from college is point A. What's the probability he will not graduate from college? So we just do 1 minus 0.80, which is 0.2, or 20%. And that's called the complement. Alright, so then we're going to get to multiplication rules. So when two events A and B are independent, which means they don't affect each other, the probability that A will occur is the product of each event. So here's the symbolic notation. David has a basket of caps. In the basket there are 6 red caps, 3 yellow caps, and 7 green. He takes one cap and records its color, puts it back in the basket, and then draws another cap. What's the probability of taking out a yellow cap? So 3 out of 16, followed by a red cap, 6 out of 16. And when I multiply those together, I get 9 out of 128. Alright, so a card is drawn from a deck, replaced, and a second card is drawn. Find the probability of getting a queen. There are 4 queens out of 52, and then a black card. There are 26 black cards out of 52, so I'm just going to multiply those together. And I get 1 out of 26. Alright, and then here's the next multiplication rule. So when two events A and B are dependent, the probability that A and B will occur is the product of A and B given that A has already occurred. So there's your symbolic notation. An urn contains 6 red marbles and 4 black marbles. 2 marbles are drawn without replacement from the urn. What is the probability that both the marbles are black? Okay, so there are 10 marbles altogether. 4 of them are black. We've taken one out. We've not replaced it, so now we only have 9. There were 4 black marbles. We took one out, so now we only have 3. So 4 out of 10 times 3 out of 9 is 2 out of 15. And then the next one, a card is drawn from a deck, not replaced, and a second card drawn. Find the probability of getting a queen, then a black card. There are 4 queens out of 52 cards. We didn't put it back, so there's only 51. Alright? And then we're going to draw a black card. Okay, so there are 26 black cards, but you already took away one of them that was a queen, so there's actually only 25 now. And then when I do this multiplication, I get 25 out of 663. Alright, so try your assignment. Let me know if you have any questions.